Hello everyone, this video is a demonstration of a Lego robot using a Raspberry Pi and the Dexter Industries BrickPi. First I'll show you the robot in action and then I'll explain a bit more about the hardware and the software. This robot is called Manti and it's one of the official LEGO Mindstorms NXT 2.0 bonus projects. You can find building instructions for the original robot on my website, and if you want to build this one, all you need to do is replace the NXT brick with a Raspberry Pi and the BrickPi. The BrickPi shield has support for up to 4 motors and up to 5 sensors. Here I'm using just 3 NXT motors, a touch sensor and an ultrasonic sensor. Okay, so let's have a look at the hardware. The BrickPi started out as a Kickstarter project, which turned out to be very successful. I pledged for one of these shields and it arrived a few weeks ago, but you can now order them straight from the Dexter Industries website. To use the BrickPi, you simply connect it to the expansion header on the Raspberry Pi, and there you have your robot. It's roughly the size of an NXT brick, but now you have the power of a Raspberry Pi with features like 2 USB ports and video output. I use one USB port, for example, to connect a Wi-Fi dongle to the Raspberry Pi in order to program it remotely. When that's done, you can connect NXT sensors and motors to the BrickPi and build your own Lego robot. The BrickPi requires a 9-volt power supply. My BrickPi is shipped with a cable to connect a 9-volt battery, but I'm using standard rechargeable batteries with a simple battery box. You connect 9-volt to the shield, which in turn powers the Raspberry Pi through the expansion header by regulating 9 volts down to 5. As you can see, the Raspberry Pi is now starting, so it's time to look at the software. You can program the Raspberry Pi and the BrickPi in many ways, but if you're just starting out with the Raspberry Pi, I suggest you try the tutorials on the Dexter Industries website. They provide examples for projects in Python, Scratch and C. They've also got a ready-made SD card image to get started quickly. You can write and compile programs on the Raspberry Pi itself using the command line, but I want to show you another method which I think is more convenient. I've set up a C++ cross-compiler for Raspberry Pi to use within Eclipse on my desktop. In the video description you'll find links to the tutorials that I've used to do this. As you can see, I've got my code window here. I have my local file system, the remote file system with the files on the Raspberry Pi. I've got a terminal through which I can still talk to the Raspberry Pi if necessary, and I've got a terminal which is used when the program is running. The nice thing about this setup is that you can run the program with a click of a button. If I press run, my program will be compiled locally, it will be transferred to the Raspberry Pi over the network, and it will begin running while giving feedback through the terminal. Okay, let's give that a try. You can see it compile there. And there it goes. Well, that's it. I hope you enjoyed it. I've provided the source code for this robot on my website, so feel free to try it out and let me know what you think.